What's up? I'm Vin, and today I want to show how to use the product rule in calculus. So we're going to go through these 4 examples here. Here's the formula, and let's get started. So for this first question here, we have f of x equals x squared times e to the x. And anytime you have the product of 2 functions where you have an x in each of those functions, you're going to use the product rule to take the derivative. So what we do is we let u equal the first term in the product, which is x squared, and then v could be the next term in the product, e to the x. So what we want to do is to use this formula is we're going to calculate the derivative of each of those pieces. So we're going to have u prime is equal to 2x and v prime is equal to e to the x. So here, if I want to find the derivative f prime of x, then all I have to do is take the product of u prime v, that's going to be 2x times e to the x, and I'm going to add that to uv prime, which is going to be x squared times e to the x. So this is our final answer to the first question. The only extra thing I would do here, because it's going to help for the next unit, is factor out a greatest common factor of x e to the x. And then you would be left with 2 plus x. The benefit of doing this is that for the next unit, when you have to find something called critical points, it helps when your derivative is in factored form. So this is our final answer to the first question. So for the second question here, g of x, we have sine x times tangent x. And same idea, we're going to let u equal the first term in our product, and we're going to let v equal the second term in our product. Now just know, if I said u equals tangent x and v equals sine x, we're going to get the same answer, but it's just I'm used to writing u as the first term in the product. So we're going to have u prime, the derivative of sine x is cosine x, and then v prime, the derivative of tangent x, is secant squared x. So then when we want to find g prime of x, our derivative, we're doing u prime times v. So we have cosine x times tangent x. And we're going to add that to uv prime, which is sine x times secant squared x. So we could stop here, but we could simplify this a little bit. We could rewrite this as cosine x times the identity for tangent x is sine x over cosine x, which will cancel out one of these factors here. We have cosine over cosine canceling out. And then we have plus sine x times secant squared x. So if all we have left is sine x plus sine x secant squared x, we could factor out a sine x, and we'll have sine x times 1 plus secant squared x. For our third function, we have h of x equals x to the third natural log x. To find our derivative here, we're going to let u equal x to the third. That's the first term in our product. And then we're going to have v is equal to natural log x. So what we want to do here is we're going to find u prime, the derivative of x to the third. We use power rule, and we're going to have 3x squared. And the derivative of natural log x is going to be 1 over x. So now when we want to find h prime of x, we're doing u prime times v. So we have 3x squared times natural log x plus, and now we have uv prime next. So we have x to the third times 1 over x. So these two here will simplify. X to the third over x is going to simplify to x squared. So this x cancels out completely, and it reduces this power to a 2. Which now, if we rewrite this, we have 3x squared natural log x plus x squared. So if we want, we could factor out a greatest common factor of x squared. So we have x squared times 3 natural log x plus 1. And we could leave our answer like this. This is a acceptable form for our final answer. Or if we want, we could use properties of logs here and send this 3 in front of the natural log x back in as an exponent. And we could also say that our answer is x squared times natural log of x to the third and then plus 1. So now for the last question here, we have w of x is equal to x squared plus 1 times tangent inverse x, or you could call it arctangent of x. And we're going to let u equal this entire factor x squared plus 1. So this entire thing is going to be equal to u, and then v is going to be equal to tangent inverse of x. So from here, if we find u prime is just 2x. The derivative of x squared plus 1 is just 2x. And now the derivative of tangent inverse of x, or arctangent of x, is 1 over 1 plus x squared. So now when we find our derivative, w prime of x, this is going to be equal to, we're going to have u prime v, so we have 2x times tangent inverse x, plus, and now for uv prime, we're going to have, I'll write this in parentheses, we have x squared plus 1 is our u term times 1 over and we'll write it as 1 plus x squared. So we have 1 plus x squared on bottom. But notice these are matching terms here. These factors match entirely, so x squared plus 1 could cancel out 1 plus x squared over here. I could write this as x squared plus 1. It's the same thing as 1 plus x squared by commutativity of addition. So then our final answer to the fourth example, we're just going to have 2x tangent inverse of x plus 1. So one last thing I'll mention before we wrap up this video is the most common mistake that I see with product rule is anytime people forget product rule, let's say I just make one up, I say y is equal to something like x sine x, is when people take the derivative, I'll say don't do something like this. Don't say y prime is equal to 1 times cosine x. What people tend to do is they just take the derivative of each piece like this. But this would be wrong. And if you want to convince yourself of why this is wrong, think of something like y equals x to the 5th power. We know the derivative of x to the 5th is 5x to the 4th. That we could just find by using power rule. But if I rewrote this as y equals x to the 3rd times x to the 2nd, you could see why that this doesn't work if we use this idea of taking the derivative of everything from left to right. Because watch what happens. If we take the derivative of the first piece, we get 3x squared, and the derivative of the second piece is going to be 2x. But when you multiply 3x squared times 2x, that's going to give you 6x to the 3rd power. See, this gives us 6x to the 3rd, which doesn't match the true derivative here, which should be 5x to the 4th. So that's why this method here for finding derivatives is not valid. Okay, so just make sure when you do use the product rule that you are, in fact, using this formula here. Because once again, the most common mistake is people take this derivative and just write u prime v prime. Okay, well, this is going to wrap up this video on using the product rule in calculus. If you found this video to be helpful, please like and subscribe. It really helps me grow the channel. And if you got any requests, just leave the topics you want me to cover in the comment section below. And thanks for watching.